390 light-years away. Our unthinkable lead is completely out of this world. In actuality, there is no discernible difference between 6 trillion miles and 1 light-year. We have embarked on a voyage that transcends time itself in humanity's resolute desire to uncover the universe's hidden mysteries, seeking answers to ancient questions woven into the fabric of existence. Recently, the unblinking eye of the James Webb Space Telescope has detected a fleeting glimpse of a structure that starts before the stars are seen. More questions than it answered, this wonderful phenomenon seemed older than the real cosmos. Is the theory of how things came to be at fault, or is there a plan that predates our universe? Come along on an adventure led by the James Webb Telescope's discoveries. The mysteries of a development that dates back 13.8 billion years are waiting for you. We have only just began the process of unraveling these massive riddles. An elderly star known as HD 114283 is near the Libra constellation in a far-off region of the universe, around 200 light-years away. This legendary explorer travels through space with enthusiasm, providing fascinating insights into its terrible history. Exactly 12 billion years ago, when our Milky Way was just getting started, it swallowed up a dwarf galaxy that had once been its home. The remarkable age of HD 114283, however, is what really captures our cosmic attention, not simply its quick cycle. It is still one of the oldest celestial objects we have seen, and it has been given the charming nickname Methuselah star, in contrast to the biblical character Methuselah, who is said to have lived for 969 years. The most recent estimations suggest a slightly younger time of 14.46 billion years, with a margin of error of 0.8 billion years, compared to the initial estimate of an astounding 16 billion years. Astronomers were perplexed by this discovery regarding its age because the cosmic microwave background estimates the universe's age to be 13.8 billion years. The age of the star, the age of the cosmos, and even the precision of our dating techniques were all seriously called into question by this problem. Let's dissect it. Determining the age of heavenly objects can be somewhat challenging. For example, stars like the Sun are intriguing to age because they are like immortal lights that have maintained their size, warmth, and brilliance for billions of years. Changes in hue and brightness are used as hints by astronomers, who compare them to models that forecast how stars will change over time. The rate at which a star spins is one indicator of age. Over time, stars slow down like a wheel. Gyrochronology is a brilliant approach that astronomers have developed by comparing the rotating speeds of stars at different ages. Additionally, magnetic chatter, flares, and surface energy emissions reveal the age secrets of stars. Because they are space detectives, space researchers can listen in on stellar discussions thanks to their powerful signals. They utilize sophisticated methods, such as astroseismology, to listen for vibrations brought on by waves moving through the core of a star. The age of a star can be ascertained by analyzing its vibrations. For example, using this technique, space experts calculated that the Sun was 4.58 billion years old. Returning to Methuselah star, the outdated communication surrounding it is not merely erratic. By analyzing its cosmic origin, astronomers assigned it an elderly age. Depending on how much bling or heavy elements like iron they have, stars can be grouped. Our Sun, a member of population 1 stars, is a metalhead. In contrast, Methuselah star has fewer heavy components and resembles an old remnant of population 2. Cosmologists can play cosmic archaeologists and uncover the age histories of these celestial species thanks to the celestial winkout. Consider theoretical population 3, a collection of stars that are still hidden in the background and haven't yet come into view with our telescopes, but which astronomers believe may be the universe's oldest jewels. With nearly no heavy atoms, space researchers believe these stars may be the creation myths. We must go back to the early years of the universe, immediately following the Big Bang, in order to understand the cosmic plan. Imagine an infinite kitchen that is primarily composed of hydrogen and helium, the primary elements of the universe. Approximately 92% hydrogen and 8% helium, or, on average, roughly 75% hydrogen and 25% helium. The population 3 stars were the first to appear on stage in this cosmic ensemble. They were huge and hot, quickly burning through their fuel and turning helium and hydrogen into heavier elements. These heavy components were dispersed throughout the enormous expanse as these early astronomical monsters erupted. The population 2 stars came next, marking a late but important period in the early history of humanity. Iron in particular was one of the hefty metals that weighed down their initial materials. Numerous of them completed their stellar life cycles, exploding as supernovae and contributing additional heavy metals to the universal mixture. After advanced gas clouds mixed with relics of the previous population 2 stars, the population 1 stars, including our Sun, emerged as cosmic rookies. The main query at this point is whether the extensive narrative challenges the ancient Big Bang theory in any way. It is difficult to understand. The twist is that there is a 70% possibility that the Methuselah star, an ancient celestial wanderer, is around 13.66 billion years old, which is in line with the universe's age. Additionally, there is a 30% likelihood that the age of this old star deviates from accepted cosmic law. Additionally, there is a 15% probability that it is much younger but not as old. Consider expecting a specific outcome when you roll a conventional 6-sided die. One thing is certain: no matter what these cosmic bins throw at us, Methuselah star is the granddaddy of stars, not simply a massive veteran. We came up with an incredibly accurate age label for it. This is where things start to become very cool. Let's reverse the galactic script rather than pondering how Methuselah may be 2 or 3 billion years older than its cosmic neighbors. What if the cosmos is older than we previously believed? Earth wouldn't even join the cosmic hammer until the very last second of December 31st. If we were to turn the entire history of the universe into a cosmic calendar, with the Big Bang serving as the most amazing New Year's fireworks. We've been attempting to grasp the vastness of space. Only the latest 10 seconds are covered by human-written history, which is merely a snapshot in time. Our astronomy experts use old starlight that was created a few 100 million years after the Big Bang to estimate the age of the universe. Redshift is the cosmic transformation of this light, caused by the expansion of the cosmos. After calculating expansion and distance, experts determined a general time of 13.8 billion years. But wait, things are going to become fascinating with the Big Bang scenario. According to a study from the University of Ottawa, the cosmos may be 26.7 billion years old. Fritz Zwicky, a Swiss astronomer, developed an intriguing theory in 1929 that Professor Rinder Gupta discovers is appending our knowledge of the cosmos. According to this hypothesis, light particles, or photons, gradually lose energy as they move over the vastness of space. Gupta suggests a cosmic trade-off, but this theory isn't entirely consistent with what our telescopes have seen. He proposes a hybrid explanation for the redshift phenomena by combining this hypothesis with what we now know about an expanding universe. Hold on tight, for it's no easy task to change the universe's age to an astounding 26.7 billion years. By fusing the light loss theory with evolving coupling constants, which are the creation of theoretical physicist Paul Dirac, Gupta gives the cosmic mix still another twist. According to this theory, particle interactions can have evolved throughout time. Hey, the cosmic clock has been adjusted by scientists before. Edwin Hubble believed that the cosmos was only 2 billion years old in the 1920s. Since then, like a gigantic leap into our enormous comprehension, we have advanced our astronomical math and increased the age of the universe. It remains to be seen, though, if this new viewpoint will become the standard throughout the galaxy. One thing is certain: the universe is a storehouse of age-old miracles and limitless inspiration, regardless of whether human history is a mere blip of 10 or 5 seconds in the larger scheme of things. The Milky Way, our immense backyard, is the scene of a breathtaking, massive tango taking place in the universe. Compared to their counterparts in other galaxies, stars on the outside of our universe appear to be strutting their stuff in slow motion, according to recent estimations. What's the scoop about astronomy? There are a few theories, and one of them is that dark matter, an invisible, enormous ingredient, may be running low in our Milky Way. The gravitational dance of large objects is influenced by this elusive material. Dark matter, the enigmatic material that is invisible to the naked eye but appears to play a gravitational back-and-forth role in the cosmos, is a heavenly riddle. The idea that scientists may have been misestimating dark matter is one option that is appending our extensive knowledge. Perhaps our universal compass is pointing in the wrong direction. The Gaia spacecraft of the European Space Agency enters the cosmic spotlight at this point. It offers intricate insights into the dance of our Milky Way's almost 2 billion stars, acting as our equivalent of an astronomical examiner. Think of it as a test of cosmic development. Astronomers have re-examined their cosmic notes in light of the satellite's accurate measurements. Our long-held beliefs about the velocity of the stars at the farthest margins of our Milky Way appear to be being challenged by their apparent slower motion. In what ways do star speeds reveal the bulk of a galaxy? It's similar to estimating a party's size based on how fast everyone is moving. Using the data from Gaia, space experts calculated the combined mass of the gas, dust, stars, and that elusive dark matter in our galaxy is estimated to be about 200 billion times that of our Sun. The twist is that, although it sounds like a cosmic heavyweight, it's actually several times lighter than we previously believed. Our dark matter estimations may have been a little too large. Perhaps there is less dark matter in the universe than we previously thought, according to one idea to solve this astronomical conundrum. But wait, it's like trying to measure the impossible, a galaxy. There may be some anomalies in the data, or we may need to make some corrections to our cosmic measuring tape. Nevertheless, additional research groups have joined the cosmic analysis, and they all appear to be singing the same chord. If this astounding discovery is true, it would be like starting a new chapter in our cosmic physics course, a turn of events that could force us to reconsider not only the Milky Way but the entire universe. According to Case Western Reserve University space specialist Stacy McCarr, this could be a cosmic game-changer. Astronomer Vera Rubin and her sizable team embarked on a cosmic mission in the 1970s with the intention of examining the motion of stars in several galaxies. According to the Cosmic Rulebook, stars on the periphery of a galaxy should move more slowly than stars near the center, much as how Mercury is the eternal speedster while Neptune takes its time orbiting the Sun. Rubin and her colleagues found, however, a cosmic shock. Stars and galaxies far from the galactic dance floor were traveling at almost the same pace. Imagine a huge disco where everyone is dancing to the same beat, regardless of where they are. The existence of dark matter, the invisible heavyweight champion that surrounds galaxies in enormous halos, was suggested by this enormous discovery. Consider early astronomers such as Kepler and Copernicus. Even though we've learned a lot since then, we're still the newbies, awestruck by the wonders of space and attempting to discover the secrets of the cosmos. Our Earth, encircled by innumerable stars in our little system, is like a tiny island in the great ocean of space, revolving around the Sun. Even when the results surprise us, the core of scientific inquiry is our search for meaning among the stars. This insatiable curiosity propels us deeper into the cosmos. It's an endless process in which every answer raises new queries, guaranteeing that our fascinating investigation never ends. The vastness and intricacy of the universe never cease to amaze us. Every new finding reveals the underlying principles that underpin our reality and draws us further into the complex fabric of cosmic history. Current studies have demonstrated that galaxies are not separate entities, but rather are linked by a complex network of gravitational and dark matter forces. We must re-evaluate our models of galaxy creation and development in light of this knowledge. The idea of gravitational waves, ripples in space-time brought on by some of the most extreme phenomena known to man, such as merging black holes or neutron stars, is one of the most intriguing parts of astronomy science. These waves, which were first discovered in 2015, provide a fresh perspective on the cosmos and reveal details that conventional telescopes might overlook. By providing a window into processes that electromagnetic radiation cannot see, they enable astronomers to investigate early universe events and deepen our comprehension of the underlying forces at work. Exoplanets, or planets circling stars outside of our solar system, are another topic of inquiry. The likelihood of life beyond Earth is seriously called into doubt by the finding of possibly livable worlds. By identifying these far-off planets using methods like transit photometry and radial velocity measurements, we are able to uncover other planetary systems that contradict our presumptions about how solar systems should evolve. Some of these exoplanets are located in the habitable zone of their stars, which may provide ideal circumstances for liquid water, which is essential to life as we know it. Artificial intelligence is becoming more and more important in the analysis of massive volumes of data as we delve further into the cosmos. New celestial bodies and phenomena can be discovered at a speed that was previously unthinkable because to AI systems' ability to identify patterns and anomalies in celestial light curves. This partnership between AI and human intuition ushers in a period of unparalleled cosmic discovery.